Hello and welcome, everyone. Welcome back from the food coma. The food was so good that I kind of felt a little bit dizzy afterwards. But the previous talk was so awesome that I immediately woke up. So I'm 100% awake. How about you? You're yeah, at least some. Great. My name is Michael. I work at AWS in the open source observability service team. I had to look that up. If you want to reach out, there is my Twitter handle and my Amazon email address in case you're doing email. In this first part, I need your participation. So if you are capable of, please come along with me. Imagine it's in the middle of the night and you're in the cockpit of a plane. What would you prefer? This view or this? You're in control, you're in charge, you're responsible for human life. I guess that the majority of you probably, even if you don't know everything, prefer that. Why is that so? Because you don't want to fly blind. You don't want to, just go somewhere and hope for the best. You want to know what's going on, even if it's not good news, even if it's ooh, going down, but you can do something. You can, react. That's the core of what I'm going to talk about today. Getting to actionable insights, and the way how we do that is with open source. So let's get a little bit more technical in our cloud native field. Imagine a good old monolith. Could be some web e-commerce system, doesn't really matter. There are a number of interfaces to external systems, payment, etc. And if you peel back and look what's in there, all these modules, right? If you've done a good enough job, it's very easy to take that apart and to spread it out, what is nowadays called microservices, right? It's not that hard. There are a few pros and cons of these microservices. Again, if you have done a good job in modularizing your monolith, it's fairly straightforward to get that into this microservices architecture. It's a feature velocity. If you have been around in the previous talk, you might have gotten an idea. It is, at the end of the day, a polyglot system, right? You're dealing with different kinds of data stores, get the best data store for the task at hand, very often with different languages, right? You might use Java for the one, Python for the other. And at the end of the day, for your users, there is no, this entire application or website is down, right? You might be on example.org and you might not get some ads, right, really bad, but you can still shop. That's great, right? It's not the entire system down. One functionality might be missing. One of these microservices might be misbehaving. Great. So let's do all of that. But hang on. There are also a few cons. At the end of the day, these microservices might potentially run on different nodes in the cloud and wherever. So it is a distributed system. Who of you has ever heard about the fallacy of distributed system, the network thing, right? Yeah, okay, cool. It is a distributed system, so there are latencies, there are things that can go wrong. The network is not perfect. It's also about complexity, right? If I ask you, here is a Java web server, where is the problem? Every one of you is easily able to point at that thing, here, at that monolith. If I ask you, where here, in 15 different microservices serving a HTTP request, where is the problem? How do you actually know where along the request path is the problem? And that leads us to observability. So if you think of the first slide, you don't want to fly blind. And I keep repeating myself. So what I did, based on working with many customers and in open source, blah, 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 I compiled my top 10 list. I'm not claiming that this is the overall and there is a lot of data scientifically there. This is just what I noticed over the past couple of years. And really, you only need to remember number 3, because there are many, right? The one thing that I'd really like you to remember from this talk is, whatever you're doing here, think of the return on investment. Think of what you're putting in there in terms of instrumentation, whatnot, what you get out of it, right? Can you really have actionable insights or not? And if not, probably it's not worth it. There are a number of things in there in terms of retention, telemetry. We're in a much better place now with OpenTelemetry than we were a couple of years ago. Instrumenting stuff, the single pane of glass, right? Where you go into the customer and say like, what's that? That's our single pane of glass. Oh, right. And what's that? That's also our single pane of glass. And what's that? Oh, that's also... Okay, so maybe there are more than one single pane of glass. It's still a big problem that we're facing is correlation of signals, right? You might be alerted. You jump at the dashboard and go like, oh, I see what's going on there. Can I actually get to some traces? Can I get to some logs? How easy is that? Is that manual? Is that hard? Or can you just click and get there? Login, right? You want to make sure that you know what you're doing and to what extent. It's not about login or not, right? Just pick what kind of login you want. And buy versus build. So you should always think about what of the stack you really want to build yourself and own, because you're going to be on call or whatever for that. So let's step back a little bit and talk a bit about the basics here. If you think about your entire system on an abstract level, you have these sources. And I colored them orange because I work at a company that uses a lot of orange. And that means that's not up to you to instrument or whatever. We expose certain things. You get logs, metrics, or whatever. You can only decide if you want to take it, if you want to use it or not. But this thing up there that's called app, that's your responsibility. If you're writing a function and put that into Lambda, then you can instrument that. If you're using EKS for containers, you can do that, right? You can instrument your code. If you've been around earlier on, Julius showed you already a little bit in terms of instrumentation. That's your choice. Where, how much, what do you actually expose? Then there are the agents. And as I said, luckily, we are moving into an area where we are more or less standardizing on OpenTelemetry as a agent. And then there are destinations. All the rest, the sources, agents, and so on, that's costs, right? That's where you have to invest. You need to instrument, you need to deploy agents, collect, etc. What you really, as a depending on your role, are interested in are the destinations. You want to look at the dashboard. You want to have an alert or whatever, right? That's what you're really interested in. But in order to get that, in order to consume that in the destinations, you need to do the work before telemetry. A slightly different way, if you split that out a little bit, just to give you an idea that there are many, many moving parts and independent layers. So one concrete question might be, I have an application running on EKS on Fargate. I'm interested in metrics, so I'm obviously defaulting to Prometheus. I have a Go application. I want to use the A.dot collector, and I want to consume it in AMP and display it in AMG, which is our Grafana version, a Grafana managed service. And given that there are so many, and that's just, you see the dots, right? That's just what we have. There are many, many partners, many, many options there. It can be quite overwhelming to find the right way. Is there even a right way? And I would argue, not necessarily. There are better ways and there are trade-offs. Talking about signals, you sometimes hear the pillars. I don't really like the pillars. They're just signal types. And the three most important ones, logs, pretty much everyone. Has anyone in here not ever emitted or consumed any kind of log line? Yeah, you probably would reveal yourself that you're a PM or in sales. So I get that. So usually logs is not something that you need to motivate. Metrics is usually still something relatively new. Thanks to Prometheus, we are now in a space where we have standardized on something, and it's more or less a matter of adoption, where and how to use it. But it's not something I really need to explain a lot in customer cases. Traces is still relatively new. It's not totally obvious why you want to benefit from that. And one use case, if you think back of that microservices architecture in the beginning, the simple question, where does something break down or where is something slow, distributed tracing can really help you there. It allows you to track that request along the request path and drill down into whatever microservice you need. So I would say without distributed tracing, the microservices setup, you're almost flying blind. Or you're doing manual correlation throughout the logs with timestamps or whatever. Not great. Yeah, just going to go through that quickly. The number one thing, there was a really great podcast, I'm going to link to that recently around that, that it's structured, and if you can, standardize that, that would be great. But at least, I don't need to tell you too much about logs. That's pretty widely used. Here, the main thing that I find sometimes challenging, specifically when you are familiar with logs, is that these metrics are numeric values. Right? You have, I don't know, 10,000 bytes read in the last 10 minutes or whatever. That's actually pretty slow, right? But it's a numeric value. And then given that you have things like Prometheus, you have also dimensions there, right? You can actually say this is, bytes versus whatever, CPU cycles or whatever. But still, it's a numeric value, right? So in a sense, it covers a lot of things, but if you ask me, can you just simply replace the log lines with metrics, then my answer would be not really, right? It serves a different purpose. Julius might disagree, but that's at least my experience. Traces, as I said, think of it in the context of a microservice setup, that it's really this across or along the request path. The question is sometimes then, what about the monolith? Does it make sense there? Turns out, yeah, you can totally do that, right? You can, and if you have a big monolith with many different modules, although it's pretty easy to pinpoint to say like, well, this is this binary or this char file, it's still very useful to look through how different things play together. So it's not necessarily distributed, but there it kind of like makes a lot of sense. So you typically have things like a map showing you how all these different services play together. And then you have the individual traces where you can drill down and essentially have, just like you have in a browser when you open up the developer view where you see in a waterfall model, okay, it spent so much time here, and then you have dependencies, and you can break that down and visually immediately see, oh, most of the time on that request is spent in this microservice. So maybe if I want to optimize things, I should do that and not the 15 others. That's an individual trace there. I picked 3 what I call success stories, partially because they are very widely known. I hope I don't need to introduce too much, but they also have different dynamics, and I'm just going to walk you through. Prometheus, you might have heard when you were earlier here in the talk by Julius, has been around. It feels like forever, like since the beginning of CNCF, since the beginning of time. But it's not the only one. There are others in CNCF addressing one of the things that I take it Prometheus by design did not focus on the long-term storage. So if you want to store data and federate and want to query over longer periods of time, you end up using things like Cortex or Thanos, right? They still have the Prometheus interface and PromQL support, etc. But it's really an ecosystem. I just wanted to make sure that you understand when I say Prometheus, I immediately think and the ecosystem around that. Hugely successful, and although very often used in combination with Kubernetes, this is not something you need to, right? You can perfectly use Prometheus even if you don't use Kubernetes. Grafana has a totally different dynamic. It's done and more or less owned by Grafana Labs, so it's a single, in that sense, single open source project. The power here, and you see it very often in combination with Prometheus, right? You see this combo coming up very, very often. And that's not a big surprise. And to me, the big advantage of Grafana really is that it provides a uniform interface. So if you think about having 5, maybe 10 different data sources that deliver certain signals, you might have CloudWatch, and you might have Prometheus, and you might have databases, whatnot, right? Each of those data sources speaks a different language, right? In the one case, I need to talk PromQL. In the other case, I need to talk some whatever AWS way to talk to that data source. But through Grafana, you have a uniform interface. Yes, there are some people in an organization that actually need to somehow understand how to write a PromQL query. We're increasingly getting there, bless you, to make that less of a burden. But the majority of users has essentially 2 or 3 ways to interact with that data source. Select the time range, click on something, you have variables there, you can say, okay, by region, by cluster, by whatever. And this uniform interface, I'm not sure if that's widely enough appreciated, how powerful of a mechanism that really is, right? Doesn't matter what your backend talks, what kind of query language, whatever. You can interact with that, you can correlate, you can query that backend. You can see metrics, you can see logs, you can see traces, etc. Right? It has some challenges that come along with that, because as with every wonderful abstraction, once it starts to leak, then you have challenges, right? But in general, that's the most powerful thing there. It's a wonderful plugin system and everything, but this uniform interface, that's really unique. So you see, for example, these are traces from X-ray, service map, and so on. The third example that I picked is OpenTelemetry, which is different to the other two because it's not really, excuse me, an end-user facing, something that you can do in a browser or whatever, but it is a set of specifications and the SDK and an architecture across a number of programming languages. So there is this high-level architecture where you say, okay, you have your application, very much the same way as with Prometheus directly, where you instrument stuff. You have your collector. That would be the agent, could be local or in a more centralized place, that gets any kind of, and we get to that in a moment, any kind of signal into a backend, into a central place, the destination that I called early on, where you then can consume it. You can correlate it, you can query it, you can dashboard it, you can alert on it, etc. The right-hand side, although you might not see it in detail, says things like C++, .NET, Java, PHP, Python, Ruby, etc. And that means that if you are interested in getting on board with OpenTelemetry, the likelihood that your language that you're using, that your company is using, is covered by it is quite high. There is a warning, a fair warning there. Not every signal type at the current point in time in OpenTelemetry is at the same level of maturity. We're going to get to that in a moment. Just to give you an idea how it works, within a collector, remember that's the agent that takes care of routing, whatever you want to call it, the signals from where they are produced, from the sources to the destinations. There are three parts to that. There's the receiver that kind of like looks at where the data comes in. There are the processors. You can do some kind of manipulation. Like the simplest case, you can just batch certain signal types or signals. And then there are the exporters to the respective backends, to the destinations. And that combination of these three things, receiver, processor, and exporter, is called a pipeline. And I picked ours because that's where I'm most familiar with, so the AWS distribution for OpenTelemetry. And OpenTelemetry is, in a sense, made to accommodate and be used through distribution. So very likely you will end up, depending on whatever backend you're using, whatever destination you're using the distribution of that vendor. But the point is, it's a de facto standard, and at least theoretically, you should be able to switch those collectors. Given that we have the Cloud Native Day, I thought it makes also sense if we look a little bit at observability at CNCF. And you might have noticed one thing. Yes, this is just one part of the landscape. There are quite a few things. And the blue ones, that's the actual CNCF projects. I get to that in a moment. There was also, by the way, and I hope you folks are doing that again, wherever Chris is, please do that again, this radar, which is really nice from an end user perspective, right? Saying like, what do people that actually are using it in production see in terms of maturity, in terms of uptake? I have the link there in case you want to have a look at that. It's recorded as well, so you don't have to read it. In terms of the different projects, there is Prometheus, Jaeger, and Fluent Bit, which are already graduated. There is Cortex, Thanos, and OpenTelemetry, which are incubating. And there are a few more, OpenMetrics. And I also put Chaos Mesh and Litmus. I'm not 100% sure if I'm CNCF compliant, if that's the official way, but I think we still, when I say we, I'm talking about the tag observability. That's the kind of like across those different observability projects, providing things like feedback and doing outreach and coming together and exchanging ideas and promoting things. I think we still kind of consider those things also part of that responsibility. But the point is, different open source projects in CNCF have different levels of maturity. And for yourself, if you're asking yourself, should I deploy X, Y, Z for a certain use case or whatever, you should take that into account as well. That doesn't mean that just because Cortex is incubating, that that's bad or whatever. I'll tell you a secret. We're using Cortex as the backbone of AMP, right? It's not a secret, we blogged about it, but it's always nice to pretend it's a secret. So it's absolutely production grade and it's absolutely there. It's just, these are certain criteria, and you know that from a graduated project, you can simply expect certain things. Doesn't mean that a project that is incubating doesn't already fulfill that to a certain extent. There was recently a discussion around, there is so much open in observability. Can we have some kind of, categorization or whatever? And actually, Dotan from Logs.io put a nice blog post out there and just trying to visually summarize that. We initially had in CNCF 2 projects, OpenCensus and OpenTracing, which both focused on the tracing signal types. Luckily, those 2 communities looked at each other and looked at what they're doing and decided, well, it makes a lot of sense to join forces and to come together under the OpenTelemetry umbrella. So it's now OpenTelemetry. So you can, to a certain extent, unless you're looking at old GitHub issues where it says like, oh, are you supporting X, Y, Z? And at some point in time, the question should really be, are you supporting OpenTelemetry, right? As I said, traces, they are in GA. If you look at anything in terms of OpenTelemetry support for traces, they are in GA. In terms of metrics, I have this dotted line here between open metrics, I get to that in a moment, and this part, to make it very clear that this is not two, opposing things or whatever. There's a clear, standard in the way how you represent metrics on the wire, which comes from I think it's the Prometheus exposition format that's originally what was called, that is now becoming open metrics as an IETF draft. And in OpenTelemetry, there's a working group making sure that this plays nicely together, which at the end of the day means that there is a wonderful compliance program, a program that makes sure that anyone who claims to be open metrics, there is a set of test cases, and if it passes that, then it can call itself. Is it compliant, Julius, or is it, what's the official wording? I think it's compliant. Right? Compliant, right, compliant. Don't want to make any mistakes here. So my hope, so this is not a promise, but my hope is that by end of this year, we can get metrics in OpenTelemetry into a place where it's GA ready. The logs are still work in progress. It's still a lot of upstream work, so in the OpenTelemetry community to get logs standardized. And there are many different players in the field, and there are many different proposals. But this is still something where, if you have any input, if you have suggestions, if you want to be part of it, I beg you, please do. I really want to, and we really want to make sure that we get the logs also into place so that we can really standardize on OpenTelemetry for any kind of signals, rather than you having to use 3, 4, 5 different agents. As I said, open metrics is coming up IETF standard, or RFC. And that is something that, to me, because it's a very straightforward and easy to in contrast to OpenTelemetry, which covers a lot of ground, a lot of terminology and semantics and so on, straightforward things. So if you are nowadays in a state where you have logs already covered, everyone does that, and consider, should I be doing metrics? The answer is almost always yes. Then the next question should be, but what standard? The question is not a real question. You should be standardizing on open metrics. Cool. And I would probably get into troubles if I would not mention that we also offer something there. That's my part that I play in this service team. There are what we call AWS native services. You probably have heard about CloudWatch and other things there. And then there are a number of open source based solutions, managed Prometheus, managed Grafana, and OpenSearch. And obviously, there are a number of things, if you think about Jaeger or if you think about Fluent Bit logs, I mentioned already, that's not yet covered entirely in OpenTelemetry, that are partially, it depends where in this chain from source to destination, are kind of self-managed. Sometimes depending on the offering, for example, if you have EKS on Fargate, there's an integrated logging solution based on Fluent Bit in there, where your interface is simply a config map, and we run Fluent Bit for you. In other cases, you need to run it yourself. But the goal or the direction is to make all of that more integrated so that you have less work and you can essentially rely on open standards. And that actually brings me to the summary and the most important takeaway points, if you wish. I very much believe in the freedom of choice. Best of class for a use case or a workload. That means you should be pragmatic about that and, should I choose X, Y versus Z? And this specifically around in the open source communities, it's sometimes hard to assess how active, how alive a certain community is. How do you do that? By GitHub issues, by how many meetings they do. So it can be challenging. So there is a little bit of homework for you there, but you have the freedom of choice. Make use of it. Unless I totally failed to make it clear, rely on open standards. Right? This will really go a long way. If you rely on those open standards, there is a kind of common understanding amongst observability providers and vendors and so on to say, let's make the telemetry table stakes. Let's standardize on something so that we can focus on the higher value stuff, on something that people are really interested in. Can I, click on it in Jaeger or on Grafana or whatnot, and not have these turf wars on the telemetry level, which is a lot of costs if you think about it. If you are a developer and you need to re-instrument your application every 3 months, that's costs that you can't ship features in that time. Whereas if using standards, it's relatively easy. You might use a different provider, you might use a different distribution of OpenTelemetry, but you don't need to rewrite, you don't need to re-instrument your code. Same is obviously true for sources that are not under your control. Make pressure, tell your vendor of choice, please standardize on open standards. The last point is really, again, comes back to return on investment. I very much believe, and I have data points to back that up, that building portable observability systems is really paying off in the long run. Meaning, if you have some workload on premises today, and you have a setup where, for example, using Prometheus and Grafana, etc., moving that into the cloud is straightforward. Whereas if you have different, mixture of proprietary and standards and whatnot, you're having a hard time. And again, think of it, you do not want to fly blind, but this can't come with the cost that observability, whatever it is, be it how many CPU cycles your agent sucks up, or how much time you spend as a developer instrumenting, or whatever it is, that is bigger than the actual functionality that you're shipping, right? So you as an individual probably want to minimize the effort that you have there. But, and we had that also, I was very pleased to hear that in the previous talk, this intrinsic motivation that should you be on call, and given that in the cloud, the less hardware you have, the less people that are actually sysadmins you can call and say, hey, can you do that for me? You as a developer, you are the one responsible. Think of a Lambda function. Who will be on call if not you, right? There might be a different team that has these responsibilities or whatever, but at the end of the day, there is no one in your organization who provisions a server. So, yeah. So think of that specifically in these contexts where you're moving. Just one example, there might be things like that you're moving from one cloud provider to the other. I've heard such a rumor that there are other cloud providers, so that could be the case. But in any case, if you want to move between different systems or have to, it really pays off in the long run. Okay, I haven't seen the 5-minute sign, so I'm assuming I'm still good in time. So I will just leave that here, put together a recipe site if you're interested in that. That's specifically to AWS. The majority of the other things were not specific. I just wanted to highlight a little bit where we contribute and where what we are using, what open source we are using in our managed services. And yeah, I would love to have a discussion. I intentionally tried to keep it as short as possible to actually have a discussion with you. So thanks a lot, and let's talk.
Yeah.